Welcome back to my YouTube channel Infinite Knowledge, and I am back with again a renewable energy source concept, and which is a solar, wind, grid, and battery integration. So all the sources are integrated each other and fed supply to the household load. So I have already uploaded the one video regarding it, and which is a very basic simulation compared to this one. I have upgraded this simulation.
Meet
This one
CodeRabbit,
is a
the
new
AI-powered
simulation
code reviewer.
and very
Get a
accurate output that
comprehensive,
we are getting
context-aware
in
code
the
review
and as
within
previous
minutes.
one,
We
previous
address the
video,
pain
I
points
have
of code
already
reviews.
considered
It provides line-by-line code
conceptual
change suggestions.
calculation
Imagine
in
chatting
the
with a bot
rules.
that not only answers
What is your
questions about your
price
code
of
base,
your
it learns from your
electricity
conversations
so
and gets
calculated
smarter over time.
according to
It
our own
integrates
requirement
seamlessly
and
into your GitHub and
according to
GitLab
the solar
repositories.
and
Merge
wind
your PR
availability.
10 times faster
So I
with
think
CodeRabbit and
this
ship
is a very
quality
good
software with
simulation and
confidence. Try it for
very
free
accurate
now.
simulation compared to previous one. Yes, obviously
www.coderabbit.ai.
there is an advantage and disadvantage of the each and every simulation, but this is a more accurate and more stable simulation as compared to previous one.
If you're a web
So
designer, here are
again,
4 Wix
I
Studio
have
features you
already
gotta
uploaded
know.
the videos and which consider
What
each and
happens
everything. The
get
introduction
power
part
either
and
of wind
what is the basic problem definition is
satisfactory
already
voltage by
covered in my
solar energy,
previous
and
one
if
video.
wind
You can see you can get the video in the description box, or this is the thumbnail of this. So yes, let it be. We are just focusing on the basics of this simulation, and then we will continue. Okay. So yes, obviously it's a solar, wind, grid, and battery. There is a four different sources, and that is integrated each other. So this is the index that we will cover. What we will cover in the next few minutes in this video, and then it's the problem definition that I've already explained, but just giving you the overview that most electricity is generated from the non-renewable sources. Non-renewable sources means coal, gas, oil, nuclear energy, which will complete or which will empty in the future. So once these resources are used up, they cannot be replaced. So we have to find any alternating energy sources which is a renewable that we can get again and again and again. One another point is in rural area, continuous of electricity is very low. In the rural area or in the villages area, the continuity of the electricity is very low. Continuously electricity failure is happening. So at that time, if you want a continuous supply, then you have to be some alternate source like a battery, like a solar, like a wind. So you will get a continuously power whenever the grid is failed. Okay. In another major issue, fossil fuel is a pollution. Pollution is major concern because nowadays temperature rise concern is very high, and that is caused uh, the non-renewable sources mostly cause the increasing the carbon dioxide level and the pollute the environment. Okay, so this is a simple problem definition. You can change according to your requirement also. This is the introduction. What I have considered in this simulation. So it is a logic behind this project is to integrate a multiple sources as you already know about it. There is a different 4 to 5 multiple sources which integrated each other. Solar, wind, grid, and battery are integrated or interconnected and supply electricity to the household load. Here I have considered the 8 kilowatt load. You will check in this in the next few slide in the simulation part. Okay. So with the help of sun energy, solar energy, wind energy, electricity can be generated. Solar with the sun energy, we can generate the energy from the solar radiation. And wind for wind, we can generate a wind speed. Okay, energy. But this is not fixed and various continuously depend on the weather condition and the wind speed condition. Okay, to get a proper supply and a frequency, here I have developed a logical controller. So what I have done, I have developed the logical controller. Why? What this logical controller actually doing? Logical controller continuously measuring the power generated by the solar and wind and change according to the requirement, according to the load limit. So there is no any low voltage or voltage variation happen at the load side, and you will get the fixed voltage at the output side by continuously monitoring the all voltages, like a solar voltage is generated by the power generated by solar, power generated by wind, power generated by grid, and all the things are continuously monitoring and change the supply source according to the requirement. Okay, so we will check it on the in the new slide. So what is the basic? This is a very important. What is this thing tells us? Okay, so what it means? It means that in the daytime, if the solar energy is sufficient available, obviously the sun is in the available in the daytime. So if in the daytime, if the solar energy is sufficiently available, then the total load would be taken by the solar energy. So only a solar panel or solar energy will tackle your total load. And our total load is nearly 8 kilowatt. You will check in the simulation. So 8 kilowatt load will be tackled by the solar energy. With the same situation, if the sufficient wind speed is there. So in the daytime, if sufficient wind speed is there, then solar and wind both are merged or both are synchronized, and both combine to tackle the load. So it will both combine and tackle the total load, that is 8 kilowatt. Contradictory, in the night time only wind is available. Obviously in the night time solar is not available, and only the wind is available. And if it is sufficient, then the wind would be tackle the total load. So in the night time, if your wind is sufficient, higher wind speed, then wind will tackle the 8 kilowatt load single-handedly. Okay. At the final stage, if no any renewable energy source is available, so no any renewable sources available, so it will again go back to grid. Okay, that is obviously, because if solar and wind are our first priority. If solar and wind are available, we have to go with the solar and wind. If any one of it fail or both are fail, then and then we have to go with the grid. And when we back to the grid, so we are now taking the power from the grid, so it also increase our electricity bill consumption. Okay, so your price of electricity will increase if you are taking power from the grid. That is obvious. And finally, if the grid is also fail. It what it means? Grid is also fail. What is meant? There is no wind, there is no grid, there is no solar, there is no any source. There is only a battery. Battery would tackle the total load for 5 to 6 hours as per its rated capacity. So I have designed one battery which is at 100 ampere hour. So our battery would take nearly 5 to 6 hours if there is no any other source. So battery single handedly tackle all the load, all the 8 kilowatt load for 5 to 6 hours. Okay. So this is how you can design the system. It's a introduction part, and this is a very basic. This was a very basic, and actually this is actual, you can say, the framework of this our simulation. According to this logic, our simulation is working. So yes, advantage reducing the electricity bill and renewable free of cost available, only initial investment required, and there is negligible running cost. Okay, so these are some basic advantages of renewable energy sources. And right now, most companies are going with the green energy concept and carbon footprint concept. So that is also helping to get this certification also. Okay. So what is the basic a block diagram? It's a very similar to our previous video. So yes, there is a one common DC bus which has a 700-volt DC bus, and I have considered the 700 volt to get the 415 voltage at the grid side, nearly three phase. We are mostly getting the voltage from the grid is a 415 50 hertz in India. In another state or another country, not a state, you might get some another voltage level also. But yes, we can design that voltage level also. Just similar, to change the some valuation. So wind is also generated 700 volt nearly. Solar is also generated 700 volt nearly, and battery is also generated 700 volt nearly. And then is one common inverter that invert the DC supply to the AC supply and pair to our load. It's a residential load. And if there is no any wind, there is no any solar, there is no any battery, I can say, because battery is also charging from the grid. The charging circuit is also there, and even battery is also charging from the wind also and from the solar also. So battery is charging in every scenario. Battery is charging from grid also, battery is charging from solar also, and battery is charging from wind also. But sometimes if battery is totally discharged, there is no solar, there is no wind. At that moment, your grid is feeding your load to with this supply 415 volt and 50 hertz. Similarly, inverter is also designed to get the 415 voltage and 50 hertz as the output side as our load requirement. So this voltage, yes, there is some variation. There might be some variation in the voltage from 400 volt to nearly 430 or 445 volt, which is obvious. Even in the grid, we are not getting the fixed voltage. It is vary according to the load requirement. So there is some variation is there, but it is a negligible. Okay, and that is okay, or that taken by our load. There is no any major concern with it. So yes, we are getting this voltage range in the output side. And yes, this is a different scenario, and what this scenario tells us, this I am giving you the this is a scenario. As per scenario, I have developed different model. Okay, so now we are at a major part of this video and very important part of this video, because this actually describe you how the simulation is working and how you can uh, work or run, I can say, how you can run your simulation according to our requirement. So what is a scenario one? What is a scenario one? Only grid power is available. So what is mean? Only grid is available and remaining sources are not. Only grid power is available and totally load fed on the grid. Total load is our 8 kilowatt load is totally on the grid. So grid is feeding our 8 kilowatt load. Our load requirement is taken by only grid. Meanwhile, solar and wind is not available and battery is charging on grid. So even the battery was previously discharged, it is also charging on. So this is one first scenario. So what is it? So this is a basic simulation diagram. This is our grid part. This is our load part. This is our inverter circuit and filter circuit. This is our solar part. This is our battery part, and this is our wind part. Okay. And yes, if you want to check this in the simulation, you can check here also. Yes. So you can see this is the wind. This is a grid part. This is a grid part. This is a solar part, this is a battery part, this is a wind part, and finally they are merging at a DC bus. This is a 700-volt DC bus. Then it is go to the inverter circuit and the filter circuit, and this is our final 8 kilowatt household load. You can here measure the active and reactive power. This is the voltage, this is the RMS supply voltage. So you can check the what is the voltage, RMS voltage finally in between your two phase uh, line to line voltage you can measure here. And yes, this is the common part. You can see there is one common bus is created here also. This is a common bus. This is a final inverter. This all the things are merged because this all generated are the DC voltage, solar, battery and wind. And there is a one final breaker as well as in the grid also. There is one final breaker here. So this is the common bus. So by this common bus we can charge our, you can see, battery. This is a reverse charging. We are taking the so if it is grid power is available, then from grid your battery is charging like this way. So and if your solar is available, then your battery is charging from this way to this way. But there is one catch: you cannot charge your battery when your battery is fading to load. At that moment, this breaker should not be in the closed condition. It should be open condition. Otherwise, your battery is fading to the load, power to the load, as well as your power come back to this position to this position to this position, and battery is charging. So battery is charging it by itself. So this condition should not happen. Okay. And again on the wind also, so wind is generating power that flow to this way, and again it can charge battery also and heading to the load requirements, the 8 kilowatt household load. So yes, you can see its basic logics are there, some logical controllers are there, and that is used to on and off the breaker on the different condition. There is some closed loop system also to generate a satisfactory output voltage. This is a closed loop system which is continuously PID tuning, which maintain our 700 volt at the output side. So this is how the simulation is designed, and simulation is very accurate. And yes, so what we have to do right now? So yes, you can see we are going with the scenario one. Okay, so scenario one is 8 kilowatt household load getting power from the grid only. So yes, I have already explained the 8 kilowatt load is here and it is getting the power from the grid only. So I am checking, and so okay, so there is no solar is available as it is in the night time and it is a daytime. Again, so battery is charging. Okay, so the battery will get charged by here, and there is some logical controller also. If my battery is less than 90%, battery charge is less than 90%, then my breaker will be closed and my battery will be charged. Initially I have put battery as a 50%. Okay, and the wind is also not available. By turning off two switches I can uh, uh, control the input wind speed and remove the voltage generation from the wind. Okay, so just I am starting the simulation. It might take some time to simulate, but you can see very clearly the battery is also charging, and the load is also getting some nearly 400 volt, the three phase voltage. Okay, so yes, you will get these types of waveform. Yes, you can see it's a very clear AC waveform, and you can see instantaneous voltage 408 volt. So it is RMS voltage at our load side. Okay, and you can check the battery was initially 50%. It is also getting charged. You can see charge and some current, and this is a 700 volt maintaining the voltage. And you can check the power also. You can check the power requirement also. So yes, the simulation is started, and your this breaker is open condition. Why? Because there is no power from the solar, there is no power from the wind. Okay, and the grid is available. So yes, obviously, yes, you can see this one is one means this two breaker is on, and I think you can see here your battery is getting charged. You can see there is some slide notch here. I am just uh, slightly increasing, slightly scope. So it's indicate your battery is getting charged on the grid, and grid is feeding to the power to your load. Grid breaker is 1, it means it is closed condition. It's a very simple simulation, and you will get in the description box, and I will explain each and everything by Google Meeting with you. Okay, so you can see here it's nearly 8 nearly 8 kilowatt load. So if 24 hour you are taking power from the grid for 8 kilowatt load, your power consumption would be 51,840. So this is your monthly electricity bill. If you consider monthly basis, then your monthly electricity bill is 51,840. So it is a nearly 52,000 rupees if you continuously taking 8 kilowatt load, and if you are taking power from the grid continuously, and 9 rupees per kilowatt is your charge nearly. So then your electricity bill is 52,000. So which is a very high. Okay. So that is why it is not recommended to only consider the grid, and that is why recommended to go with the renewable sources also. Okay. So I think scenario 1 is completed at this moment, and we can continue with the scenario 2. So the scenario 1 is your grid is able to supply your load and battery is charging. What is the scenario 2? The solar power circuit. So solar will tackle the 8 kilowatt load. So now only solar is there, and it will take the total load. So how you can create this scenario? Yes, there is some logic. The daytime different condition of radiation are there. So you need to switch on the circuit and switch off the circuit, because it's not a night time, it is a daytime. So it is a daytime, there is satisfactory radiation, there is a satisfactory voltage generation, and battery is charging. Okay, so yes, not cloudy weather, and not like daytime cloudy weather and not. I have not considered the cloudy weather here. I just removed it. In the previous model, I have considered the cloudy weather also. So here there is the two simulation switches, daytime and the night time. The battery is charging through the solar power. Obviously, battery is also charging. Normal situation, daytime toggle switch in the on position. Okay, and if you want to check the output waveform here, you can see here. This is the output waveform whenever the grid power supply is available. Okay, so it is very clear waveform. Now what I am doing, everything is okay, but just I am starting this breaker. So once the solar is satisfactory generated, solar voltage, the grid breaker automatically gets switch off, and this breaker is automatically get switch on. These two breakers, and grid breaker is isolated. Whenever some satisfactory voltage is come, so voltage is generated. It takes some time to generate the voltage. Solar is generating the voltage. So once the voltage is greater than 650, this breaker is on, and the totally load fed by the totally load taken by the grid, not a grid, solar only. Grid is isolated, and your battery is getting charged. So total load will be taken by only solar once this breaker is closed. So we need to wait. It takes some time. This 650 is the limit voltage. Okay, once this limit is threshold, you can see this breaker is on. This breaker is on. and now the grid breaker is closed. Okay, it's a 0. So grid breaker is closed. So even though grid is available, but it is isolated. Why it is isolated? Because solar and wind is our priority. It is a renewable energy sources. Whenever these two sources are available, grid automatically isolated and the total load taken by only a solar. Okay, and you can see here the waveform you are getting the voltage also which is very nearly 415 voltage. It's a three phase voltage, and yes, you can see here there is some initial spikes and then it is stable. So yes, you can see here it is transfer from grid to solar, and now solar is, yes, there is some voltage ripple. It's obviously present because it's a LCL filter and the inverter circuit, and you cannot design a pure sine wave inverter. It's a very too much complex for this much amount of load and this high ampere. So yes, it is very nearly to the sine wave, but obviously there is some ripple is there. Okay. So this is the supply taken by your load, and your battery is also getting charged. You can see the breaker is closed. So you can see here the on the solar your battery breaker is also in the battery charging breaker is also in the closed condition. This is a one. So it's clearly indicate your battery is getting charged on the solar only, and the remaining all the breakers which are the grid solar and it's a grid wind, all the two breaker are in the off condition. So this is how you can develop the model specifically for solar, and solar is continuously fading load to the 8 kilowatt load also, and charge your breaker also, charge your battery also, not a breaker. So you can see initially it is a totally on the grid, but after some time it switch over to the inverter part. Okay, so you can see the waveform is very clear, and yes, obviously, and the scenario 2 is completed. So you can see here this is a three-phase inverter circuit, this is the solar circuit, and yes, initially your solar toggle switch in the daytime, wind is off condition, and battery is a 50%. So it is the sine wave, and this is the inverter waveform, and yes, grid to solar conversion. It's clearly indicate you are transferring from the grid to solar part. You are getting voltage also 420 volt. So whenever satisfactory voltage is generated by solar, at instant power source change from the grid to solar. Only a satisfactory voltage come, then and then it should be switch over from the grid to solar. Okay. Then this is the battery charging condition. Initially battery was 50% charge. Yes, there is some slightly drop and then it is getting charged. Okay, so initially battery was on the 50%, so the battery charging starts from the 50%, and it clearly indicate the slope is clearly indicate that your battery is getting charged. So now we are going with the third scenario. So now the third scenario is wind power source circuit. So now totally the power fed by only a wind circuit. So what I have to do, I just turn on these two toggle switches. So I am just turning on the two toggle switches. As per use the toggle switch on wind turbine, so I just turn on both the switches and checking whether any another switches are on or off. So I can check this is in the off condition. Okay, and this power fail is off. So initially when I start the simulation, my grid breaker is in the on condition because wind takes some time to generate a satisfactory voltage. So you can see here. Okay, so my grid breaker is in the close and the power fed by the grid. Parallelly, my wind turbine is start uh, generating the voltage. So you can see the voltage is generating, and once the voltage come to greater than 675, then my breaker will be closed. So yes, obviously it takes some time. So just we are waiting here, and yes, you can see here. Uh, Solar breaker switch is off condition, wind is normal wind speed, and battery is a 50% charge. So once the solar is satisfactory generated the voltage, you can see it transfer from the grid to changeover from the grid to wind. So initially the power fed by the wind, then it is totally transfer on the initially power fed by the grid, and then after at a particular moment, this moment the grid breaker is isolated and the wind breaker come to picture and totally power fed by the wind only. And you can see here there is a voltage uh, it is a 434 voltage. It is nearly our in between 400 to 445 voltage. So it's a 434 voltage that we are getting at the output side. This is a totally in the wind side, and this about the grid side. Okay, and this is a changeover period. This sound. Solar was in off condition, wind is on condition, battery was 50%. Okay, you can see here the battery is getting charged on the wind also, only wind in the picture, and this is a voltage stability after some time, because wind takes some time to stable. After some time you can see voltage come to the in the stable condition due to PID tuning. Okay, so this is how it's working, and yes, obviously we need to wait some time in the simulation. It's take lots of time to generate a voltage. So until now we are going further. What is the fourth scenario? Solar plus wind power source available. So in this moment, what is fourth scenario? Solar and wind both are available. So if you go through these scenarios, the first scenario was our grid power. So we have already gone through it. What is a grid? Only a grid power is available, and grid is totally fed total load. Wind in solar is not available, and battery was charging on the grid. Second was our only a solar power is available. Solar power available and total load fed by the solar power. Wind and grid is not available, and battery is charging on solar. So second scenario we have already seen. Third scenario is running. Wind is available only. Wind power is available and supply total load. Whereas solar and grid is not available. Solar and grid is not available. And on wind also our battery is charging. So this is the scenario that we are right now focusing. And then what is the scenario? Scenario solar and wind both are available. Solar and wind both are merged. Grid is not available, and both solar and wind charge your battery. So at this moment solar is also available and wind is also available, and both are continuously feeding power to your load. So this is your fourth scenario. What is the fifth scenario? Fifth scenario is solar to wind or wind to solar power change. So as you know, in the fourth scenario, solar and wind both are continuously power feeding the power to the load. Now let's something happen and wind is gone. So wind is gone means solar to wind changeover. So initially solar and wind both are supplying power. After some time only solar is supplying power. Same in this condition. Initially solar and wind both are supplying power. After some time solar is gone, so only wind supplying power. So when solar is failed to tackle the load, wind will be single-handedly taken the load. And whenever both fail, grid come to picture and taken the load. So and vice versa. So initially solar and wind both are there, but solar fail. At this moment, wind should be tackle the load. Or vice versa means initially both are on, solar and wind. But when wind fail, not a solar, wind fail, the solar single-handedly taken the load. So both condition we will check in the future. In the sometimes means in the future slides, I can say. It's a fifth scenario. So we are right now on the third number scenario, and the simulation is working. What is the sixth scenario? What is the sixth scenario is there? Grid, wind and solar. All the supply sources are failed. Grid is also not available. Wind is also not available. Solar is also not available. So at that time, when supply source like solar, wind and grid all are in the blackout condition, at that moment battery comes to picture and tackle all the load up to few hours. So our hours is nearly 6 to 7 hours or 5 to 6 hours. Nearly 5 to 6 hours the battery is continuously supplied to our load. So this is the final scenario at which battery come to picture and discharge overload, and there is no any solar, there is no any grid, there is no any wind. So right now we are on the scenario 3, and what is this? Scenario 3 is windbreaker is closed and apply to the load. So yes, this takes some time to come to the stable condition, as we already know. After some times when it's come to the stable condition, then this breaker will get on and supply to our load. Okay, so you can see here You can see a transfer from the grid to wind. So very clear transition from the grid to wind. And now grid is feeding power to our load. It's a 408 nearly voltage that we are getting here. And my battery is also charging on the grid also. It's a one, not a grid, wind also. Wind. Battery is charging on wind also. You can see the notch. Notch is upper side. Battery. It is indicate battery is charging. So the third number scenario is also completed. Now what is the fourth scenario? Solar and wind both are available and both are charging our battery. So the wind is also already available. I just turn on the solar. Okay. So obviously once the voltage comes to the more than 650, this breaker is on. So at this moment both solar and wind both are available and supplied to the load. So yes, we have just completed the third number scenario. Then only grid power is wind power is available and wind is totally paid. And we have already checked this PID waveform also. Now fourth scenario is solar, means solar daytime. Okay, solar switch on the daytime. Yes, it is in the daytime. Obviously, it is in the daytime. And normal wind speed. Okay, normal wind speed. Both switches are on. It means normal wind speed and normal voltage, and supply is also fed by the wind. Now this breaker is also uh, in the close condition. Okay, okay. Sorry, the simulation in the hold condition. Okay, I start the simulation. So initially there is grid breaker is on condition because no solar and no wind. Solar takes some time to come into the picture. So you can see this breaker is on and this breaker is off. Initially this is on. The power fed by the grid. But after some time when solar come to picture, this breaker is on and all the power transferred from to grid to solar automatically. Okay, so this breaker is in the closed condition and at the moment this breaker is in open condition. So right now total power fed by the solar and parallelly wind is also already started and generating the voltage. So once its voltage come to the satisfactory level, this breaker is on. Okay, so here we also need to wait as per logic. This is obviously take some time to come to the stable operation due to this PID tuning. So after some time, you can see very clearly. Initially, the grid is on, then solar come to picture, and at this moment, at particular this moment, solar and wind both together and supply to the load, and load voltage is 4 to 1. Okay, so this is how the fourth scenario is working. So initially, battery was again each and every scenario battery is charging from 50% because initially battery was on the 50%. You can see here voltage come to stable, it drop, then again increase. Why this happening? This is happening due to this PID tuning. Voltage takes some time to stable out. When there is PID tuning, it's stable out after some time. Okay, so finally you can see here our windbreaker is also in the closed condition and our PID tuning is also, I think, successfully completed and come to one stable position. Okay, and yes, at this moment wind is also supply power to our load and solar is also supply power to the load and voltage is also nearly 420 voltage. So you can see the solar breaker is also in the closed condition. Okay, so solar is also feeding the power. So right now the fourth scenario is completed, solar plus wind. Now fifth scenario is there. So fifth scenario, we are switch off the solar and checking whether the wind is able to tackle the load or not. So at this moment, what we have to do, we just remove the solar breaker. So I just remove the solar breaker. I just remove the solar breaker. As the breaker is removed, uh, this is out, and now only the wind is there. Wind breaker is closed. Yes, there is some slight voltage dip was there, but wind is able to tackle all the load. It's tackle the load also. It's tackle the charging of the battery also. Okay. The Yes, it's a very clear waveform and very stable waveform. Okay. So this scenario is completed. Now what I am doing, I am again starting the solar generation, and we'll switch off the wind generation. So we will check the reverse scenario also. So this scenario is also completed. Solar to wind and wind to solar, both scenario 5, both changeover completed, and very smooth transition is there. The voltage level is also maintained. Okay, at this moment, the the solar is okay. So right now I just switch off all the switches to isolate the wind turbine. Okay, so wind turbine is isolated and grid is single-handedly tackle all the load and even charging of the battery. Okay, so there is no major transition in the voltage dip. You cannot even understand whether the load is whether the source is gone or not. Okay, so very smooth transition is there, very smooth voltage at the output side, and yes, your battery is continuously charging each and every scenario. You can see it's a continuously charging, no matter whether grid is available, whether wind is available, whether solar is available, whether wind and solar both are available. When both are available and one isolated, even though at this moment your battery is charging. So this is how the simulation is, this is how accurate this simulation is working. Understood? So right now I can say that we have gone with all the five scenarios, that is very major scenarios. And yes, the sixth scenario is very important. Now the sixth scenario is only there when the battery come to picture and battery fair to the load. Okay, so now we are go to the sixth scenario. We'll check how the sixth scenario is working. Okay, so what is explained in the sixth number scenario? Grid, wind and solar, all power sources are fail. Okay, so what I am doing right now, my simulation off condition, my wind is already in the fail condition. I am failing the solar also. Okay, so there is solar is also not there. So whenever I start the simulation, you can see my grid breaker will get on directly because no any renewable sources is there. So yes, it's on. Okay, one means it's on, and the grid is taken load to the supplying power to the load and charge the battery also. Okay, but what I am doing, I am intentionally isolate the grid supply. So yes, you can check here your battery is getting charged. Very slide upper transition. You can see slide up upper transition is there, battery is charging. So right now I am intentionally isolate the power fail condition. So whenever I turn on this switch, it indicate the power fail scenario, the grid power fail scenario. So when I start, okay, grid power is fail. So at this moment, grid power is also fail. Wind is also not there. Solar is also not there in the picture, and wind is also not there. Okay, so there is zero zero. So it is also zero. Wind is also zero. So you can see here directly your battery come to picture automatically as per logic, and it's totally fade. The battery is continuously fading power to our load, and battery is not charging at now. You can see the battery is drastically reduced. Battery reduction is start every time your battery getting charged, but right now it is getting discharged. And yes, you can see the ampere and the voltage also. So yes, here battery is getting discharged. Battery capacity is 100 ampere hour, load is 17 ampere hour. Okay, so load is nearly 17 ampere hour, continuously changing due to switching of the inverter. So it's nearly provide 5.88 hour backup. So 6 hours backup is provided by battery. So this is how this simulation is working, and yes, it's totally on the battery, and battery is right now discharging. But right now we are again back to our consumption detail. So if 24 hour you are taking power from the grid for 8 kilowatt your household load, you have to pay 51,840 rupees after a 1 month. But if you consider 8 hour solar power bank, so if in 24 hours for a 8 hour you are continuously getting solar power, so then your power consumption will be 24 minus 8. So your electricity bill was reduced 30, initially was of 51,840, then it is reduced to the 34,560. So I think it is a reduce. So initially your electricity bill was of 58,840, it is reduced to the 35 percentage, 34,560. Just if you use a solar power available. If you initially invest some amount in the solar and then it reduce your electricity bill with the 35%. Again, if wind and solar both is available, you have both renewable energy sources. You have wind also, you have solar also. So 18 hours backup is provided by this. So remaining 6 hours, only remaining 6 hours, 24 minus 18. Remaining 6 hours you have to take supply from the grid. So for that you have to only pay 12,960 rupees. So your electricity bill consumption will reduce 75 percentage. Your electricity will reduce 75 percent. Initially was a 51,000, nearly 52,000. It is reduced to the 13,000 only. If you use the wind and solar both, and if both are providing supply or supply to the load for 18 hours in a single day, so remaining 6 hours you need to take supply from the grid. Here also, if you use only solar, if you don't have wind, if you use only solar, then you will get a solar for the in the daytime. So it is nearly 8 hours. So 24 minus 8, so I think it's 18 hours. So you need to pay to the grid or to the power generation company for 18 hours power consumption, and that is a 34,000. So as you can see here very clearly, renewable energy sources are very important and very cost effective for a long term purpose, and it is also environment friendly. Okay, so yes, right now the simulation is okay and battery is continuously discharging. This is the large scenario, and you can see very clearly battery is continuously discharging. And if my grid power is again come back, you can see again it automatically transfer on the grid and my battery start charging here. Initially was discharging, but right now it's take charging. You can see this spike. Okay, so right now it start the charging over the grid as my supply come back, and you can check the voltage level also. Okay, you can see very clearly initially the power coming from the grid. So it's a very clear waveform. Then it's come to the inverter portion or battery portion, and after some time when again my power come back, it again come back to grid. There is no solar or wind in this scenario. There is only a battery and grid. So this is how you can develop this module. So I have completed this saving thing also, and these are the references from IEEE papers. And thank you for watching this video. If you have any query, just comment it. I will definitely reply. If you want this PPT report, this simulation file, you will get each and everything in a minimal cost. In the description box, I have given some details. By using that detail, you can contact me for any type of MATLAB project, for any types of electronics projects. You can contact me. I have also given my fever profile. It is also given in the description box. So thanks for watching this video, and this is the part 2 video. You can consider part 1 video is also there on my YouTube channel. You can check out that video also. It is also given in the description. Again, thanks for watching this video.